Bismillahirrahmanirrahim. This is the new topic for the laboratory techniques, and this is known as paper chromatography. So, I'm going to give you this lecture, and I'm also uploading the lab assignment also. With the this lab assignment is time bound. So, if we talk about the paper chromatography, so it is a type of chromatographic procedures. There are different types of chromatography. For example, paper chromatography, thin layer chromatography, column chromatography, gas liquid chromatography, high performance liquid chromatography, GCM gas chromatography, and mass spectrometry, and so on. But you are only here to learn the paper chromatography, which is the simplest analytical technique. Excuse me. So actually, it's an analytical procedure which runs on a piece of specialized paper, and we normally call it Whatman filter paper. So it is a planar chromatography system wherein a cellulose filter paper. Now this Whatman filter paper is made up of cellulose, and it acts as a stationary phase on which the separation of compounds occurs. So if we talk about the this paper chromatography, so what type of technique is? So this is a typical analytical technique which is used for the separation of of dissolved chemical substances. But the main point is that here we can take the advantage of the different rates of migration across sheets of paper. You know, if we apply some sample, and if the sample is a mixture of so many things, so every component of that mixture has its own mobility speed. ठीक है, उसका जो migration speed है, यानी कि traveling speed है, वो different है. So that's the principle which we use for identifying the different components in the mixture. It's a very powerful analytical tool. और सबसे जो important aspect है paper chromatography का, or I can say on the broad spectrum, that chromatographic separating technique is useful because this analytical tool requires a very small quantity of the sample. So this is very important. Now, next slide में you can see that this one is the unknown mixture. Now, this unknown mixture is made up of 4 different inks: red, blue, yellow, and green. So when they mix together, so this is the sample. Now when they apply this sample over here, okay, this is the solvent line, and when one drop of the mixture was applied over here, okay, and then this paper was put into this beaker containing the solvent system. Okay, so solvent system is the mobile phase, right? And as the edges of the bottom of the filter paper absorb the solvent, it moves in the upward direction. You can see a thin line over here. This is so far the solvent has been moved. So as the solvent moved or absorbed, the mixture of the ink is separating into different colors: yellow point, green point, red point, and blue point. You can see the obvious independent ink components on this paper. So next we go to the slide, and this is the paper chromatographic apparatus. Okay, and this is the suppose calculations for the blue ink and everything. For example, if I explain to you this thing, you can see that this is the origin of the sample. So and this is the end of the solvent. When it reaches the end, we calculate the distance. For example, this distance is 10 centimeters. Now then we see that there are 3 drops over here: red colored drop, purple, and blue. So the distance traveled by the red component from the origin is only 2 centimeters. 6 centimeters for purple and 8 centimeters for blue. So paper chromatography, it has become standard practice for the separation of many complex mixtures like amino acids. Instead of this inks, you can take the mixture of amino acids, peptides, carbohydrates, steroids, purines, and there is a list of simple organic compounds. Even inorganic ions can also be readily separated by the paper chromatography. So in the upcoming slides, I will explain you that how we use these distances to calculate the RF values. Then we come to the principle of chromatography. Principle of chromatography is very important to understand. Okay, so the principle involved in this chromatography, when the substance are distributed on the partition between liquid phase. So ये जो आपका है सारा ये पार्टीशन डिफरेंस, मैं इसको बिल्कुल सिंपल आपको बताऊंगी, कोई टेक्निकल वर्ड्स आपके साथ यूज नहीं करूंगी बिकॉज यू आर टू young for this concept. So let me explain you in my simple words. Um, the principle involved is partition chromatography, wherein the substances are distributed or partitioned between the liquid phases. यानी कि जो आप एक combined spot लगाते हैं उसमें ये मतलब separate होते चले जाते हैं. अब डिफरेंट फेसेस हैं वहाँ पर. एक तो फेस आपका वाटर का हो गया या सॉल्वेंट का हो गया, विच इज़ हेल्ड इन द पोर्स ऑफ द फिल्टर पेपर. और दूसरा उसका एक मोबाइल फेस होता है विच मूव्स ओवर द पेपर. सो एक आपका फेस होता है वाटर का फेस, ठीक है, और ये वाटर होता है जो आपका फिल्टर पेपर है विच इज़ मेड अप ऑफ सेल्यूलोज. उनके जो पोर्स होते हैं उनमें ऑलरेडी मौजूद होते हैं. दूसरा जो मोबाइल फेस होता है विच मूव्स ऑन द पेपर, ठीक है, और ये मोबाइल फेस आपका सॉल्वेंट सिस्टम होता है जो कि मूव करता है. सो इसी की बेसिस के ऊपर हम सेपरेट कर लेते हैं अपना मिक्सचर. हाउ डज इट वर्क? Substances are distributed between a stationary phase and a mobile phase. So I have told you कि अगर आप in the broad way में इस पेपर को ले लें stationary phase और जो solvent system है आपका, you just take it as a mobile phase. So when a colored chemical sample is placed on a filter paper, the colors separate from the sample by placing one end of the paper in a solvent. So हम पेपर के एक एंड के ऊपर, अभी आपको मैंने इस स्लाइड पे शो किया है कि एक एंड पे हम लगा लेते हैं पेपर, और जैसे ही सॉल्वेंट जो है वो एब्जॉर्ब होता है, ठीक है, when the solvent is absorbed by the filter paper containing the spot of the mixture, and this mixture is made up of different inks, और वो separate होना शुरू हो जाते हैं like this. if you मैंने earlier आपको थोड़ा सा explain कर दिया था, explanation upcoming slides में. So then the question is, what are 2 types of paper chromatography? So different है, ascending है, descending है, circular है, सब कुछ है, लेकिन आप ascending paper chromatography जो है, और दूसरी होती है 2-dimensional paper chromatography. Ascending तो simple है, जैसे just you have done with the mixture of these. But what about the 2-dimensional paper chromatography? So the mixture is separated, okay. The mixture is separated in the first solvent, which should be a volatile. पहले हम एक first we use the solvent which is highly volatile. Volatile means जो easily vaporize हो जाए, for ether हो गया, alcohol हो गया. Then we dry the paper, और उसके बाद हम उसको different angle से we put in the angle of through 90 degrees. We again put into the same tank, and the same tank will have the second type of solvent. So 2-dimensional paper chromatography means कि अगर हमने एक पेपर क्रोमेटोग्राफी जो है वो इस तरह की है, ठीक है, तो दूसरी जो है आपका जो ये आपका पेपर है, ओके, दिस इज योर पेपर, ठीक है. सो सेकंड हम ऐसे कर लेंगे पेपर को, चेंज कर देंगे उसकी डायरेक्शन. सो टू डायमेंशनल लेते हैं इसको, excuse me, so that we can have the maximum separation of the mixture. अब टाइप्स ऑफ क्रोमेटोग्राफीज हैं. टाइप्स ऑफ क्रोमेटोग्राफी बहुत ज़्यादा हैं. बहुत द मोस्ट कॉमन इज द लिक्विड क्रोमेटोग्राफी, गैस लिक्विड क्रोमेटोग्राफी एंड गैस सॉलिड क्रोमेटोग्राफी. और इनकी बड़ी एप्लीकेशंस हैं which is used extensively used in the forensic labs. This again is the diagram of the paper chromatography. Now we come to the applications. So applications may fermentations, to study the process of fermentation and ripening, to check the purity of pharmaceuticals, to inspect cosmetics, to detect contaminants in drinks and foods, to examine reaction mixtures in biochemical laboratories, and to determine dupes and drugs in humans and animals. तो ये बड़ी है और ज़्यादातर हम इनको forensic laboratories में use करते हैं. So then we come to the RF value. RF value actually means retention factor, and this is defined as the distance traveled by the compound divided by the distance traveled by the solvent. For example, if a compound travels 2.1 centimeters and the solvent front is 2.8, when dividing both, you will get the value of the RF value. What is the purpose of calculating the RF value? So RF value, especially in the chromatography, we know the distance traveled by a given component is divided by the distance traveled by the solvent front. तो reason इसका ये है कि for a given system at a known temperature, it is a characteristics of the component. हर component की अपनी RF value है और इसी I mean information को we can apply and can be used to identify different components in the mixture. So this is all about your lecture for the paper chromatography, and I will upload the assignment also. So today I'm going to upload 2 labs with 2 lectures. Okay, thank you so much.